Hi, welcome to Engineering Mechanics, Statics, Chapter 7, Forces in Beams. Some introductions. In the preceding chapters, we've been dealing with determining the external forces, right? We looked at, you have some forces acting on some bodies and how does it react to that. We've also, in Chapter 6, started determining forces which hold together various members of a structure. This chapter, Chapter 7, is concerned with determining the internal forces, so things like tension and compression, shear and bending, which we'll introduce, which hold together the various parts of a given member. The focus from this chapter is on two important types of engineering structures, specifically beams, which are usually long, straight, prismatic members designed to support loads and applied at various points along the member, and cables. Now, having said that, what we are not going to cover cables at this time, so we're going to focus our efforts on beams. Okay, we're going to talk about internal forces in members. So if you have a straight two-force member, consider this member right here. Okay, it's in equilibrium under the application of F if you have an equal and opposite force minus F in the other direction. So we've done that in the past. So now let's consider this. Let's cut this at some arbitrary point C, right? So now it's cut at some point C. Well, you need these internal forces F. So if we look at this section right here, which is this portion of right here, you have this external force here. Well, in order to keep it in equilibrium, you're going to have this internal force negative F. And this portion here has this external force applied here, but you have to have this internal force F applied here as well. So in order to maintain equilibrium, you have to have these internal forces. So in the case of a two-force member, the internal forces that the two portions of the members exert on each other, this one and this one, are equivalent to the axial forces. And the axial force is the compression or tension force acting in and along a member. So the idea is that you can cut this at any point, or if you had, say, magically a spring scale inside there, you could see what the force is inside that member. Okay, so we're going to talk about some other things. Let's look at a multi-force member. So we have this frame that we've considered in the past. Let's look specifically at this member, this ABCD. So if you look at this ABCD, this cable right here is pulling in this direction. You have this thing which has an X and a Y component right here. You have this two-force member which creates just a compressive force right there. And you have a pin which has an AX and AY. So you have to have all these forces. Okay, so we're going to do the same thing. We're going to cut it at some arbitrary point here. So you have some arbitrary cutoff here. So let's look at this thing right here. So now you have this force, right? But you have to have internal forces. And these internal forces are equivalent to a force couple system. And they're necessary for the equilibrium, of free bodies JD and ABCJ. So this one's kind of easier to see, right? We just had this force. So now we have to have this force. But if it's just these two forces, it's going to spin, so we have to have the shear force, and we have to have a moment to maintain equilibrium. So we have the equivalent force couple system here. And it's the same thing here, it's just there's a lot more going on, so it's easier to look at this one. Okay, in this case, V, this force V is called shear, M is the bending moment, and F is the axial force that we just talked about in the previous slide. Okay, so also this is a two-force member, so this is a multi-force member. Now we're going back to two-force members. So what we learned about two-force members before is regardless of the shape, the forces have to be equal and opposite, and they have to point at each other. However, the internal forces to maintain a non-straight thing, it's going to have to, if you cut it at some arbitrary point here, say at this point D, you're going to have some axial force, and you also have to have a shear and a moment in order to maintain equilibrium. So for an internal force couple system is required for equilibrium of two force members which are not straight. So again, if they're straight, it's nice axial force, it's good to go. But if they're not straight, then they require this force couple system. Okay, so what are we talking about with internal forces? So these are the axial forces, right? You cut it off, you have some either tensile forces or compressive forces, things pulling it apart, pushing it together. They're along the axis of the item. Shear forces, what are shear forces? Well, say you have a couple pieces glued together and there's a force here and here. It's the force that's trying to tear these things apart. Or say you have a object like this. It's a force trying to break it in half, or here, it's the force is shearing it apart, tearing it apart. the moment, a bending moment, is the measure of the bending effect due to forces acting on the beam. So you have, here's this beam. If you have some applied load to the beam, this is hopefully your beam doesn't look like this unless it's a really weak piece of wood or something, but it has a moment. It causes a bending to it, and it's an internal reaction to a bending load. And the bending moment is measured in terms of force and distance. So it's a moment, right? So Newton meters, foot-pounds, some force and distance combined. That is what the bending moment is. So let's do an example. Let's explain this here in example 7.1.